So possible cases of inserting node is you can insert into an empty list, you can insert in the front, you can insert at the back, you can insert in the middle. These are 4 conditions which we are going to see it now. So insert as the first node will be case 1 and 2. Empty list, if you are going to insert in an empty list also first node only. If you are inserting in the front also first node only. But if you want to insert in the middle or at the end of the list will be case 3 and 4. First 2 will be the front elements only. That is beginning. Inserting at the beginning is only first 2 conditions. So here is a singly linked list. See here, singly linked list, my list A, then B, C, D. So finally here actually there should be null. There should not be a dot, there should be null. I will change it. So each node contains a value and a link to its successor. So the last node will not have successor, it should be marked as null. And the head node, the header node points to the first node. That is a default node, I told you, head node, which will always point to the first node. So using a header node, the entry point into the linked list is a head. Head is not a separate node, but it is a reference to the first node. If the list is empty, the head is a null. That is, this will be a null reference. This null only will indicate that, see, if the list is empty, head will be null. If the list is not empty, head will be pointing to the first node or holding the address of the first node. So now I think insertion at the beginning of the list alone I'll teach you, and I'll stop after this. So insertion at the beginning of the list is first 2 conditions, as I told you. You have to create a new node. Assume that the node which you are going to create is called as, name it as new node. First check whether your list is empty. List is empty means your head should be null. Okay. If it is empty, that means your head is null. Then your pointer will be like this. You have created already a next pointer. So how you have to set the in the code is set your new node. That is, the new node is the node which you are creating. This new node's next will be null, because like, see, listen very carefully. Your list is empty now. So whichever node you are inserting, that node's name I have named. See, it is like a variable only. If I am creating a variable A, I'll tell it as A of next is null. So here I have given the standard terms. Normally in practice only I have given here. It's not that you have to use only new node, not like that. This is for our practice. Normally this only will follow. So that I have given here. But this is the name of the, that is like a variable which I have given for the value. The first node to be getting inserted. That node is called as new node. So my new node of next will be null, because there are no other nodes in the list. This is my first node which I am adding. And now another one important line you have to keep it in mind is, now first initially it was null, your head was null. Now what I should do, my new node will become my head now. Are you clear with this statement? Then only I will proceed this. Are you clear with this statement? If your if your head is null, there is no node in the list, and I'm going to add my new node. So my new node has in my list there are no other nodes in the list at all. So my new node of next, that is my second field in my new node will be null. My first field will be containing the value. What is the value of the new node? My second field will be null. And now, since this is the first node or the new node, I will make this as the head node now. My reference will be head node. So now what is,
But you told that head node contains a dummy value or something.
That is initially before the list starts. Before, see, null we are giving, right? We are giving null, right? That is initially. When the list is empty, it will be null or something, some other dummy value, something. But we have to give it as null only, null. But when a particular new node is being allocated, my first node, how will I know that this is my first node? Only by means of this head. Only by means of this head pointer, I'll be knowing that, okay, this is my first node. Okay, so this is our important criteria, that my first node should be always pointed to head node. Okay, in case already I have a node A, that means my list is not empty. My node is already a new node is already a node A is there. But still I want to insert the node which I am going to insert now. That is my new node. That's the beginning of, that is before A. Anyway, diagrammatic representation of there. If I tell you this clearly, that representation will make you more clear. So if I know that already a node A is there, which is termed as head, or A which is given as head value. Now I'm going to insert at the beginning. What will happen is my new node which I'm going to insert, that next will be head, because I told you a head node is already there. That is my A node which is already there. That is my new node of next will become the head. And now since I have inserted my new node in the beginning of my head node, it should not be, the second node should not be head. I told you always the first node which I'm inserting only should be head. So once again I'll assign the new node as head. So I'll come to the diagram and I'll tell you. See here, create a new node. So this I have represented by means of C++. You can see here. You can use C++ or ML or whatever it is. So head node. So 2.5. This is my value of the new node, and this is null because there are no other values. Whenever I'm inserting, I do not know what will be the address of this. So now this is only my value 2.5 new node. I want to insert now, insert to this node now. I have to create a list now. So if it is a new node, I'll be giving this lines, new node creation, dynamic creation. Then what I'll do is, my new node is having the value, that is 2.5 number, that is now stored in here. New node's value is now this 2.5. I won't give the value here, right? Some variable which I'm taking it out. Now if it is my first node, so here in this case only head is available, which is pointed null. So my 2.5 is acting as my first node only now. So what I told you, head will be, that is new nodes next is null. So that line is only here. And my head should now be pointed to the new node. That is what here. So if already elements are there, that is if my already elements are there in the list, now see here already elements are there. 20 and 30 are already there. I want to insert now 10 to before 20. Okay, my new node 10 has to be inserted in the beginning. That is already 20 and 30 are there. So now my 20 only will be my head node now. Okay, and 10 I want to insert before 20. So in this case, what I should do is, the head node name, the node of the node value, node name I have given as new node. So what I will do is, my new nodes next will be, what is the name of this node now? It is head node. Initially it was head, right? So head node. So now my new nodes next will be head. So that's what this line, my new nodes next will be head. And my new nodes next is head. That pointer is now created. This pointer is now created. So new nodes next is head means now 20's address will be over here. But head is still remaining here only. But it is not a proper way. In my list, my head should be this node. 10 now. So once again, I will assign my new node to head. So what happens now? My 10 will become the head node now. Clear? So the entire procedure is in the next pseudocode. Now till whatever I taught you in this, all the three from here, all the three slides I have gathered over here as a pseudocode. Void insert at the beginning. I am going to, the value which you are giving is passed over here. Now my pointer node, structure node, it is new node is my node which I am going to create for each of the value which I am going to insert. So first dynamically you have to create a new node. So this is the procedure. This is my type, struct node type. That is which type is here. As I told you before, integer, no, it should be integer. But ours is holding two fields. Structure node is having two fields, integer field and a structure node type field. This is a pointer which holds the address of the next node. So struct node star malloc. Malloc is the procedure for dynamically allocating, and size of struct node, which will hold the size of this particular structure node size, integer size as well as your node type pointer address type. Both will be taken in the size of procedure. So this is what. Now this is your next line. So these lines are always compulsory for all structure node, struct node. This you can change the name if you want. You can give any name. And what name you are giving here, that name only should be taken out here for allocation. Now this particular node is having int data. If I have given int data, that only will be taken out. Okay, so in the structure node, if I'm giving int data, that is overtaken here. So new node of data will hold the value in the sense, if I'm passing the 3 should be given, 3 will be taken, stored in the new node's data. Now 3, now it is checking if my head is equal to, or I told you always you have to check for the empty condition. So if my head is null, these lines already I have told you, if my head is null, there is no value in the list. So what I'm going to do is, my new node of next will be null because I have no other node in the list. So my new nodes next will be null, and my head, my new node which I'm inserting will become the head now. Or else already I have a value, previously itself I have so many values, 20, 30, 40, 50 in my list, but I want to insert my new node as the first node. Now your else procedure will take. Head is not null because head will be pointing to the first node. So what will happen is, new node of next, whichever you are going to insert, as in this diagram as I told you, new node of next. So new node of next will be the head, and finally once again I have to make my new node as the new node is assigned to head. Don't interchange it, don't give new node is equal to head, that will be wrong. New node, from here assigning procedure, I think you know, A is equal to B means B is assigned to A, not A is assigned to B. Okay, similarly new node is assigned to head, and finally it will. So how many times you insert the value, this insertion procedure will be called in the main part, and whenever you are including the value here, a new dynamically memory will be created. Then it will check for the null condition, and if it is an empty list, this procedure will follow, else this procedure will be followed. So you want to insert at the end. So at the end means you have to find the last node. Then only you'll be knowing how to insert at the next of the particular node, maybe next to the last node. So how to find it? Suddenly, see, by visually you can tell that this is my last node, but the algo system does not know. So you have to code in such a way that anyway tracking should be from the beginning only, to find out the null node. From the head node only it has to start. So what happens is, you have to keep on moving the pointer from one node to the next node to the next, until it reaches, until your next pointer points to null. Because every node in next will be having the address of the other nodes, next nodes. So A will have the address of B node. So what happens, when you are moving from A to B, B to C, C to D, assuming that D is the last node, now D will not have a next. D will not have a next address to be pointed. Rather than D will be having a null pointer there, indicating that D is the last node in the list. So how to find the last node is, when you keep on moving a pointer from one particular node to the next pointer, when your next pointer is pointing to the null, at that time you can go and insert your new node. So that's what here it is given. Create a new node with a given. So this is normal procedure, new node. So new node, when you are initially creating, it will be as null only. So here also the checking condition should be there, whether your list is empty or not. Whatever insertion you are going to do in the beginning or in the end or in the middle, whatever you are going to do, you have to first check the node which you are going to insert is your first, is the beginning creation of a node, or it is having already the list is having some elements in it. So first normal checking whether the list is empty. That means list empty means your head should be null. So if it is empty, whatever node you are going to insert will be the beginning, and that will be the end node also. So the normal procedure, your new node of next, that is, you'll be a head will be always your nearest, your new node will be always your head. In case your list is not empty, you have some series of nodes in it. In that case, you have to find out the last node. So what you have to do is you have to create another one temporary pointer. The pointer name you can keep it as temporary pointer or next pointer or whatever it is according to your convenience. The name can be a pointer variable can be named with any name. So here if it is not empty, then you are going to define a pointer called as temp. So you are going to start from the first node, not from middle of the anything. So always your head node temp and initialize with it with head. That means your first node is now having the variable temp. There is a pointer variable called temp. Now you have to keep on moving the temp until you find it reaches to the last node in the list. That means your temp of next is equal to null. So to represent a pointer, I told you that this should be an arrow mark. So then temp of next is null or not. If it is null, then you can go and insert the temp of next will become your node which you want to insert. So we will see it in the code. I'll tell you with the diagram and then with the code I'll move. See,
Ma'am, ma'am, one doubt.
mm,
Ma'am, when you're writing temp of next
mm.
or anything of next, you're pointing to the address, right, of that
Yes,
location,
you're pointing to the address only.
not the
Okay,
value.
value,
Sorry.
no, pointing to the address of the particular variable. Okay,
All right. Okay.
yeah. So now see this diagram. In this diagram, the name which I have taken here, I have told it as temp, but I told you can use any name. Here the name which is given is node pointer. You can take any name. So for example, now you are going to trace the current position. So what you are doing is you have a, here it is not an empty list. Already you have a node 2.5 over here. The value of the node is 2.5 and it is the only node available in this particular list. In this list, don't take 7.9. Only this is my list, already available list, and the new node which I'm going to insert is 7.9. Okay, so now this node I have to insert after 2.5, not in the beginning. It is at the end after 2.5. So how to find now? Now what happens is I am initializing another one pointer, node pointer. The name is node pointer, or else temp also you can keep, anything else. So that will be is initialized to head now. Now I'll keep on moving. Here it is only one node, so just I'm going to check whether node pointer of next is null. So node pointer of next is null only, because here you can see there is no pointers more than that. It is null. So what I'll do, my temps next or node pointers next should be your new node. That means this will hold now the address of 7 dynamically. A new node's memory will be allocated and that particular address will be now assigned to this field. So what happens, 2.5, this null will now, this pointer will be having a link over 7.9 as shown over here. So my what is that, my code will be like new pointer of next is new node. That's all. New pointer of next will be new node and new nodes next will be null, because I should tell that also, because from this null is replaced with 7.9's address. Now 7.9 will have null only after that. There is no more nodes after this. So there is one
Ma'am, so
more.
the list is endless, right?
What, ma?
The list is endless. As long as we add another new node,
Yeah.
null node will be created.
Yes.
Okay.
Okay. So now see here, already 2.5, 7.5, 7.9 is there. Now I am going to add 12.6 as a new node here. So once again, my node pointer will be 2.5. That's 2.5 here. Assume as a node pointer here. Now it will check node pointer of next is null. It is not null. It has a link over to 7.9. Now the node pointer will move. So how you have to write the line is, if node pointer is not, node pointers next or temps next is not null, you have to move node pointer to node pointer of next. That means this one's next, my link is moving. Or temp is equal to temp of next. That means your value temp, pointer variable temp, this pointer will move here. That's the meaning. This variable will move over here. Pointer variable will move over to 7.9. Now 7.9 is having the variable node pointer now. Now again it is checking. Node pointers next is null. Yes, here it is null only. So what happens? Node pointer won't move. Instead, the link I will change is node pointers next will be my new node, new nodes next will be my null. Clear now? So now see here, now this is node pointer. After that I have included this to this. So initially node pointer was 2.5. It is not null. So again node pointer will move to 7.9. It finds that it is null. So now what happens is this line, when it reaches the null, append the new node at the last. That means your node pointers next will be your new node. New nodes next will be null. So together I have put it in a code here. So this is the same thing, same example only. So now see here, insert at the end, same procedure as your insertion in the beginning, only this part will change. So you are creating a new node, you are allocating memory, you are giving allocation for the particular new node, and new nodes data will have the value, and new nodes next will be all, whatever node which you are creating, initially it will be null only. So it is null. Now I told you always you have a checking condition. If head is null, that means it is the new list. It is not. It is an empty list. Otherwise, I can tell you, if it is an empty list, always my new node will be head only. Already this we have done, so I am not repeating the line over here. This is a general line. Whenever you create a new node, my new node will be assigned to head. This line will be applicable only when the list is empty. But if the list is not empty, else, so you create a new another pointer variable. This pointer temp will be, or node pointer will be useful for moving the, or for tracking the, or to find out the list, last node in your list. So temp is the one which I am creating. I am assigning, since I am going to track it from my first head node itself, you have to assign the head as the temp, and now you will be keeping on moving using the while loop, while your temp of next is not equal to null. Not equal to null, as I told you, you have to keep on moving. Temp is equal to temp of next, temp of next. So as like in this diagram, first temp will be here, next temp will move over here, then if one more node is there, it will move over here, and after that only it will insert. Here there are two nodes. So first my temp is this. It will check whether it is null, not null. So my temp will move. The pointer is moving here. So when the pointer moves here, your line should be temp is equal to temp of next. Then only your pointer temp will move to the next node. Now again it will check temp of next is null or not. Now here it, now after insertion. Now before inserting this new node, this would have been a null only. So when this null is seen, now what will happen? My temp of next is equal to the new node. That line is only here. Temp of next is equal to new node. And new node of next is null already given over here. So you need not repeat the line once again here. Understood? This is the one which is used for to insert the node at the end position. Are you clear with this? The beginning and the end. Clear? So next I will move to the next part. Inserting a new node in the middle. When you are going to insert a new node in the middle, here you have to, you need, see somewhere you are going to insert in the middle now. You need the previous position also. You need the next position also. Then only the link can be joined. Without, there should be a link from the maybe A and C is there, already there. And I'm going to insert B now in the middle of A and C. So from A to B, there should be a link, and B to C, there should be a link. So there are two links should be there. So I need two pointers for this to track the particular position. Okay, so in previous cases, 2 pointers not necessary, because only my aim is to find the last node. But here I need the previous node's value, where what it is or where it is, and the next node also. Then only I can insert and connect both the sites properly. So here also, initially the checking always, as I told you, you have to check whether your list is empty or not. That is always your checking condition. If the list is empty, as the previous lines gets repeated, your new node will be the head, new node of next will be null, and new node will be assigned to head. With that you can stop. But if there is already, there are many nodes in the list, that only we are going to see it now. If it is not empty, Then you define a pointer temp and initialize with head. Now you have to keep on moving this. And another one here, inserting a node in the middle, 2 pointers has to be created. I can name it as current pointer and previous pointer for your easy purpose. So when I come here, I have given us, so this diagram is with node pointer and previous node. But in this code, I have given us previous and current. This will help you to understand it more. So first I'll tell you diagram first, then I'll go with the code. Now see here, your head position is here, 2.5 already there, and that is called as node pointer. Now you have 7.9, you have 12.6, all these are only my nodes in the list, my previously list. I want to add at node 10.5 in the middle of where I have added, in the middle of 7.9, and that is after 7.9 I need to add this new node now. So what I'm doing is, that is first initially you assign the head as node pointer. Okay, when assigned here, you have to check whether the particular value to be inserted. Now here you have to check the location also. Here, as in the for loop, I have given a location. You can see over here. With the location, it will track. For I is equal to 1 means your first node starts with 1. So 1 it will start, and what it will do is, when it comes to the second I is equal to 2, your pointer also will move. For example, I'll tell you now, see, node pointer, it will find out my first position is 2.5, second position is 7.9, third is 12.6 as per my previous thing in the list. But I want to insert this as the third position, 10.5 new node as the third position. So what I will do, when my I is equal to 1, my node pointer will be in 2.5. And what happens is, my node pointer will move to the next node pointer, because the location which I want to insert is 3. So it is in 1 only. So my node pointer will move to the next position, 7.9, and 2.5 will be changed to previous pointer. That here I have previous node. So see here, the node pointer will be assigned to the previous node, and node pointer will move to the next. Or else you can keep temp1 and temp2. These all names is as per your convenience only. Temp1 and temp2 if you keep, you have to keep it as temp1 initially will be assigned as head. And what it will do is, temp1 is not the location to be inserted. Now it will move, temp1 will move to the next node. That is, temp1 will first assign its value to its previous value, that is temp2, and then what will happen is temp1 will move. Only after assigning it to some other variable only it can move. Before that it will not move. So here I have used as node pointer and previous node. So what I will do is, before moving my node pointer to 7.9, I will assign it to a previous node. So my 2.5 is now accessed using a pointer variable called previous node, and node pointer is moving to the next node. So now 7.9, my node pointer is in, see here, second diagram you see, node pointer is in 7.9 and 2.5 is my previous node. Now again it will check whether
but we can't just access 2.5 as the head node.
Head only, ma. Initially we will assign the head to the node pointer.
Okay, ma'am.
Okay, after assigning the head to the node pointer or the temp or the previous, whatever variable which you are using, then only you will be moving itself. Okay. So now what happens is, your second position, it is in node pointer is moving to your second position. Now again it will check whether 10.5 is to be inserted. No, the location is still in 2 only. But it will find that the next position has reached, will be reached now. So what happens is, based upon, I'll go to this diagram now, pseudocode. See here now. So these are all the values which you already know. Here I have used current pointer. You can see here. You asked me a question, right? Whether how it can. Always you have to assign the head node to the one which you are going to move. So as I have given, insert in between, I need a value, I need the location. So what I'm doing is, my new node, that is the new node which I'm going to insert. my previous pointer, my current pointer. 2 pointers I need for accessing. Now new node allocation. Make the allocation as in your previous code itself. Now new node of data value. This also I think you know it well. Now new node of next also null. You can give it here itself. No problem. Now what happens is you are assigning the head to the current node. So you are going to start moving the particular position of your head. You are not going to move the head. Keep it in mind. You cannot move the head. You are assigning the head to the current pointer. This is used for tracking now. Now what you have to do is, if it is the first position, no problem. That will be the first node to be inserted. Else, use a for loop. This for loop is for finding out this location. For I is equal to 1. So maybe your location is something you have given us 3 or 4 or something. Until that your loop will run. So now what you are going to do is, the current pointer which you have assigned as the head will be now taken as the previous pointer, like this. Now this will be your previous, this will be a previous pointer, this will be, first this is your current pointer. When your current pointer is moving to 7.9, this will become your previous pointer. 2.5 will become your previous pointer. Now when you are going to change the current pointer to the next one, the 7.9 will become the previous pointer. This is what actually happens. So now see here, this happens until you find the location only. When you find out the location, your link will be transferred like this. See, for example, now this is your previous pointer. This is your current pointer. Now I have found the location. So what happens is, now don't use the condition like shifting the condition, like don't move the current pointer to the next to 12.6. That is a wrong concept. Because we have found the location, your loop will stop. And what it will do is, this node variable is now called as your, as per this diagram, this node is, this pointer is called as your previous node, and the next node is node pointer has been moved to the fourth location. So 1, 2, 3. Third location when it comes, now we are going to change the link. How is this node accessed? Using the name previous node. How is this node accessed? Using the name node pointer. So how will you create a link for this? This node's name is previous node. So previous node of next is new node. New node of next will be node pointer.
Ma'am, so
yeah,
accordingly, we'll add 1 to each of the values after from the node pointer, right? After we have inserted, we have to add 1 to each of the next ones.
Yes, yes. See here, that is the thing is, when you cross the location, when you cross, until then your name, that is, this is for just for, why we are using 2 pointers is, I told you, when you insert in the middle, you need the previous node also has to be accessed by an variable, and the next node also has to be accessed by an variable. So you need 2 variables, different variables, where you have to access the previous variable and the next variable. Then only you can insert in the middle of the both of the variables. So what happens is, you will be first keeping the value as current pointer only. When you start moving to find the location, when the current pointer will move to the next pointer, before that it will previous one will become your previous pointer. Current pointer will move to the current pointer of next. So it will move until you find out the particular location. When it moves to the, that is to the location next of your insertion, that is your location is 3. In that case, your current pointer will become the 4th location now. Your current pointer will become the 4th location, and your second node will become your, that is, second node will become your previous location, and your 4th one will become your current location. So what will happen is, now only you are going to insert the third, that is in a third position. In that case, now a new link has, this loop will come out, and a new link will be created, like your previous nodes next will be your new node, and new nodes next will be your next node, that is your current node. Or else if you use temp1 and temp2, my temp1's next will be my new node, and new node of next will be temp2. That's all. It is based upon the variable which you create. Understood? So from this diagram, I am inserting 10.5 between 7.9 and 12.6. So if I assume that 7.9 is, where is that the cursor has been moved, and now 7.9 will be my previous pointer and 12.6 will be my current pointer now. So in that time, my correctly my new node will get inserted. So how I should change the link will be my current pointers next will be pointing to the new node, and new nodes next will be pointing to the current pointer. Clear now? My previous pointers next will be my new node. My new nodes next will be my current pointer. Or else in this diagram wise, if I need to tell, I'll be telling us previous nodes next will be my new node. My new nodes next will be my node pointer. So this line is very important. That this line only is making you to insert in the middle. This is for finding the location until you find the location.
We are inserting it in the middle. If you have to replace it,
replace in the sense,
like if we have to remove 12.5 and insert 10.9 or whatever it was,
give delete. You have to call the delete option. Delete will work over there, and then you have to give it in the location.
Okay, ma'am.
Deleting will be done there. That is, the memory should be free from the, that is, you have allocated 12.5 initially. Then you have to call the delete function. Once after that,